Hello friends, welcome to my channel Om Electronics. Today we will discuss about RF transmitter and receiver. The RF transmitter and receiver is an easy way to communicate two devices by radio frequency. The corresponding range varies between 30 kHz and 30 kHz to 300 GHz in the RF communication system. The digital data is represented as variations in the amplitude of carrier wave. This modulation is known as ASK, that is amplitude shifting key. These signals transmitted through radio frequency, that is RF, can travel long distances, so it can be used to communicate in long range applications. RF communication uses a specific frequency range to communicate two devices. In this project, we will control two relays using two receivers through a single transmitter. So this is the block diagram, transmitter and receiver. So here the push button switch are connected to the encoder IC. This encoder IC takes a 4-bit data from this push button switch and convert into a serial data. Then send this data using the RF transmitter module. The another side, that is receiver section, the RF receiver module receives the serial data from the transmitter module and it provides this data to the decoder IC. And then the decoder IC decodes this data and controls the relays. So this is the 433 MHz RF transmitter, radio frequency transmitter circuits. So this is the transmitter module, ground pin, data and VCC and antenna. And this is the encoder IC HT12E. The VSS pin of this IC is connected to the power supply ground pin, and the VDD pin of this IC is connected to the power supply positive terminal, that is VCC. And in this IC, A0 to A7, that is pin number 1 to 8, are connected to the ground terminal. Here we have used the two switches, that is S1 and S2, and these switches S1 and S2 are connected, that is AD11 and AD9 respectively. You can use another pins, that is AD10 and AD8. Here we have used only two switches, that is S1 and S2. And the 1 mega ohm resistance is connected between the two pins, that is pin number 15 and 16, which provides the external resistance for the operation of the internal oscillator of the IC, that is HT12E. The RF transmitter module ground pin is connected to the power supply ground pin, and the VCC terminal of this transmitter module is connected to the power supply VCC, and the data pin is connected to the pin number 17, that is D out of this IC. So this is the RF receiver circuit, that is 433 MHz radio frequency receiver circuits. Here we have used decoder IC, that is HT12D, and this is the RF receiver module. VSS pin is connected to the power supply ground pin, and the VDD pin is connected to the power supply positive terminal, that is VCC. And here the pin number 1 to 8, that is A0 to A7, are connected to the ground terminal, and the output, two outputs, that is output 1 and output 2, are connected to the pin number D11 and D9. And the 33 kilo ohm resistance is connected between the pin number 15 and 16, which provides the external resistance for the operation of the internal oscillator of this decoder IC. The RF receiver module, the ground terminal is connected to the ground terminal of the power supply or decoder IC, and the VCC terminal is connected to the power supply positive terminal or VCC terminal, and the data pin is connected to the pin number 14 of this IC, that is decoder IC D-in. So here we have used only two outputs. So this is the transmitter section. Only we have used the two switches, switch 1 and switch 2. This is the HT12E encoder IC, and this is the transmitter module. This is the antenna. Here we have used 7805 for supply the 5 volt power supply from the 9 volt battery. And we have used the another separate receiver module. So module number 1 and this module number 2. This is used for particular one room, and the another receiver section we use for another room. So here we can control this only two push button switch. One switch control this section, this module, receiver module, and another control the others receiver section. Now we can check. We have designed as per our circuit, transmitter and receiver. So this is the remote, RF remote switch. We have used only two switch, S1 and S2, for two receiver section, receiver 1 and receiver 2. So switch on the circuit. Press switch on and press switch 2. if we cover this section, now press switch on. So totally this is the RF signal. So we cover all this section from RF remote, that is transmitter section. Press 1, switch, press 1, and similarly section 2 we cover all total circuits. This is the transmitter section. So we can control the separate rooms only using one transmitter section, that is only one RF remote. You can control easily two separate rooms for two bulbs or two fans or another loads. So this is the very simple circuits and very stable circuit. Thank you.